We want to now look at some specific examples and see if we can put into practice the concepts we've just been looking at, the techniques we've just been looking at for creating a linear function, creating a linear equation in two variables that relates one item to another. And out on the website, you can download a PDF file. The title of the PDF file is Creating Linear Functions. And there are 7 examples that we're going to look at in these subsequent videos that will help us apply these concepts we've been looking at. So if you don't have that paper, you may want to pause the video, download that paper. It's a PDF file. You can easily print it out with Acrobat Reader. And so we'll look at each of these problems to help us understand these concepts. So let's look at example number 1. Example number 1 says, Alpine College plans to increase tuition $50 per semester hour each year. In 2003, the tuition was $375 per semester hour. Find a linear function that describes tuition as a function of years since 2003. All right, so it says find a linear function. That's y equals mx plus b, or f of x if you want to use the function notation. And it's a function of the tuition related to years since 2003. So the function value, the y value, is tuition. The x value is years since 2003. It's very important to understand when you're trying to create a linear equation, a linear function, very important to understand the two quantities you're trying to relate and which one is the y value and which one is the x value. And so here we're talking about the years since 2003 is going to determine the tuition value. So we look at the problem, and it says that in 2003 the tuition was $375. So in 2003 the tuition was $375 per semester hour. And the college intends to increase tuition $50 per year. Well now, isn't that the slope? The y value is tuition, the x value is years. If you have $50 per year, change of y would be dollars of tuition, change of x would be years. $50 per year, that's a change of y over change of x, that's my slope. And I immediately have an equation that is y equals 50x plus b. The change is $50 per year, every year since 2003. So this is a scenario in which I've been given the slope. Now, have I been given the y-intercept? Or have I been given another point? And actually, the answer to both those questions is yes. I've been given the y-intercept because x is supposed to represent the years since 2003. Well, 2003 itself, how many years since 2003 is 2003? That's 0, isn't it? So in effect, when they told me that in 2003 the tuition was $375 per semester hour, didn't they give me the point 0.375? 0 for x, because that's how many years after 2003 is, 0 years. And the cost, the tuition, was $375. So they gave me that point, but more importantly, that point is the y-intercept point. Remember, the y-intercept is where x is 0. So the y-intercept value is the b value, that's 375. and I have my function that relates tuition. Oh, maybe rather than using f, maybe we'd even use t. T for tuition. T of x equals 50x plus 375. And we have our tuition function, where the t value, the y value, is the tuition cost per semester hour, and the x is the years since 2003. And we could now use this function to answer a question. Maybe a question like, if the trends continue, then what did this function predict as the cost at Alpine College per semester hour for school year 2010? Well, 2010 is 7 years since 2003. We would put a 7 in for x. 7 times 50 is 3,500. 3,500 plus, 7 times 50 is 350. 3,500, that'd be a little expensive, maybe even for Alpine College. 7 times 50 is 350. 350 plus 375, that's going to be what? 7 1/4? So in 2010, it would have been $725 per semester hour if the trends had continued at an increase of $50 per year since 2003. So in this instance, we were given the slope and the y-intercept, and we were able to take those values and produce our linear function.